Graphical Path Method is a scheduling algorithm that was developed by Dr. Gui Ponce de Leon here at PMA. CPM has been the state-of-the-art approach to actually schedule projects. The main purpose for that algorithm was actually to prioritize tasks and identify critical work so that you can put in and manage resources accordingly, keeping those tasks on time. There are certain assumptions associated with that algorithm. Like, for example, most tasks or every task in the CPM algorithm will be scheduled at the earliest possible time. This introduces certain limitations when you are trying to model in real-time scenarios where maybe for resources, maybe for space constraints, for various other reasons, you just cannot work on all these things at the same time and you delay tasks. CPM just does not have the ability to model it inherently. Addressing these concerns is an important aspect of GPM. GPM was developed by Dr. Gui Ponce de Leon, the founder of PMA, in 2008. And it improves upon the CPM algorithm by basically addressing the fact that you can place activities on planned dates. You do not need to schedule them on the earliest possible date. And what that allows is it gives the user the flexibility, the scheduler the flexibility to actually plan how they want to execute the project. GPM basically showed how gaps are the inherent reason why float exists. On a path, when you collect all the gaps, that's where the float is coming from. And this flexibility that gaps offer is it can allow activities to move forward in time, move backward in time, kind of optimize it to the way you want your schedule to run. Typical CPM approach uses both forward and backward paths whenever you need to recalculate the algorithm when there are changes to your plan, which for larger networks could mean a significant amount of time. However, the approach that GPM takes with gaps allows it to say, hey, whichever activity is affected, it affects the gaps around it, and those gaps basically transfer the change over to its predecessors and successors, thereby just limiting the calculation to the portion of the network that's affected and not the entire network. In GPM, the self-healing algorithm allows it to automatically react to the changes that the user is making in real time. And how it achieves that is that as the user increases the duration, the algorithm detects that the gap between the next activity or its successor is reducing down. And as it reduces down to zero, it now needs to affect the successor further. And the network kind of keeps addressing that change until there is no next successor to affect, or the gap to the next successor still is sufficient to contain the change that it does. So the self-healing algorithm basically updates the network in real time for the user, giving them real-time feedback as to what changes they are making and the impact it could be having on their schedule or a milestone that is relevant for their discussion. The GPM algorithm is actually a more generic approach to scheduling. It avoids the assumption of early dates, scheduling activities on the early dates, how CPM does. In GPM, if we introduce the limitation that the drift for all the objects has to be zero, which essentially means that all activities need to start at the early dates, the results from GPM will exactly mimic the behavior you will see from a CPM algorithm. Further to that, GPM provides more flexibility by allowing you to precisely model the behavior of the project, how you want to model it. It does not need any unnecessary workarounds that further complicate the behavior or make optimization difficult for the scheduler. and helps them kind of work with cost and schedule in a better manner. The localized updates for the self-healing increases the performance for the network. And the innovative interface that NetPoint as a tool offers allows people or the stakeholders in a room to talk more collaboratively and plan their schedules in a much better way. Another unique aspect about GPM is its ability to calculate floats left of the data date. These floats are referred to as forensic floats, forensic in the sense it has already happened, and CPM tools, current state-of-the-art tools, do not really offer that feature. In a CPM schedule, things left of the data date are considered to have zero total float, or the total float isn't really calculated, essentially meaning that there is no critical path left of the data date. In your projects, as when the project's complete, an important aspect is to derive the as-built critical path or do some forensic analysis, let's say for claims. All of those aspects kind of need the ability to assess and understand how the critical path changed over time. With GPM, no workarounds are needed, no additional effort is needed to kind of get that information. As the schedule data date progresses, as the schedule is updated with progress, the floats still continue to calculate left of the data date, and the as-built critical path is available in real time to any user.